All right, welcome to Nested Loops. We're doing chapter 22, Object Pool. So I'll turn it right over to Diego.
All right, can you hear me?
I can.
Awesome. All right, this is actually a very quick and easy chapter. The object pull pattern is generally used whenever you have a resource that is expensive to create, or there's a limitation on how many of this resource you can create. So you want to reuse the resource. And the author talks about, in this case, a pool of connections, which is a typical thing, like even in an active record, we use active record base, and it establishes a connection, and it uses a pool of connection generally to handle all the connections. And we don't see in the background what's going on, but pretty much they're using an object pool pattern. The case of the author, he talks about that we're doing a Java application with a Java servlet will connect to a middleware running in C, which will connect via TCP/IP to a mainframe where it will get information. So there will be like the servlet will send it like log information. It will then send it to the mainframe. It will come back with a yes or no, this log is correct, and back to the Java applet. And the same thing for handling his portfolio. Like will be like, get my portfolio on this user, and get this portfolio for this user, and back and forth. And the thing that he wasn't sure about at the time was how to handle the TCP/IP connection and and how many he could have of each TCP connection, because potentially it's going to have some amount of Java server connected to the middleware, and it was one of the things that he was told to, like, don't care about the throughput and not how fast that your application is. So it needs to be able to connect to many Java servlet. And pretty much he becomes the funnel, and actually the amount of TCP/IP connection that he can use becomes the funnel. And again, he doesn't know at this point how many TCP connection he's gonna need, or how many it can have in total. So, and again, throughput was the primary concern. And he talks for a second, like, the right number was somewhere between 2 and 100, even though the available bandwidth could not handle more than 20. So it's probably going to be somewhere below 20, more likely than not. And one of the things that it talks about, there are, is potentially you want to tackle the high-risk issue as fast as possible. In this case, for a couple of different reasons. One, so he has a proof of concept of that it can prove, once it's solved the higher risk issue, it can show like an end-to-end implementation, and then work out all the kinks. And to implement that end-to-end solution, you have to establish a robust TCP/IP connection, determine a number that it could be used, establish the method to load balance the connection, and handle errors if something were to fail. Again, the risk were how much time would it take to become proficient in TCP/IP, because at the time he wasn't very familiar with it. And also, then if I change the number of connection, would that affect the code? Would load balancing affect the code? And would error handling affect the code? The top one, he couldn't do much about it because he had to move quickly. But all the other one, he could encapsulate them thus minimizing risk. Because if he encapsulated each one of these, it pretty much like it could then work on each thing without affecting the rest. And that's what he says. This is a general approach that works for him. He tries to look for a way to insulate himself from the impact of changes in the system. Generally, it's a good approach. Both the tackle the high risk issue first, and then encapsulating, which is encapsulating what changes, encapsulating what's a high risk is part of the principle throughout the book for the design patterns. All right. So he said he figured out he didn't have any hope of guessing what the right solution was. So he made a system where it could change the number of TCP connection without affecting the code, which means the client code would have no idea, and because it also doesn't need to know how many connections are there available. The client just need to say, I want a connection, I want to use it, and that's about it. So in order to manage all these TCP IP connection and have the ability to change them, he created TCP IP manager. So TCP manager will create the connection and would manage the connection. So as soon as we say the manager creates a connection, we know there's a type of factory. Because the connection object, the TCP object itself, it called a port, the manager of port, he aptly named the port manager. And again, the way the object pool pattern is usually also implemented is through a singleton pattern, because you want to have one location, one object that knows all the resources and manages all of them, the pool of objects, and it's one single source of truth. All right, so the way implemented is as follows. It's got data members. It has a private array of port references. There are you use a constant to define how many it's going to have. In this case, 5 port. And then instantiate all 5, assign it to an array. And if any did not instantiate it through an exception. And in this case, you said like if you cannot create 5 connection, why keep going? Because like something is going awry. And the method they started with were get instance of port, a return instance of port. And this is pretty much it's kind of like a check-in, check-out system. It checks out a port, it calls whatever call API like to the mainframe it needs, and then gives it back. And so in the way, yeah, right here. Ask the port manager for a port, use the port that's needed, release the port, so the client doesn't have to concern itself with creating ports, how many, or anything else. Let me see. Okay, this is the thing. So one of the things about this that branch it defer was error handling, which is one of the tougher problems with TCP/IP and C++. And the reason why, because the client doesn't have to take care of it, because it's going to manage it better at the port and port manager level. Like either one could handle the error completely. To an extent, the client code will be visually unaffected once it's implemented. So again, at this point, up here at the client level, like I don't need to worry about any error handling, which makes my life easy. Also, he talks about Yagni. You ain't gonna need it. Pretty much is by focusing on what's the most important at this moment, which is like the hard parts, or it makes the greatest impact without working on stuff that might not be needed, might not be useful, or might have like very minimal return on investment of the time. So so apparently he was able, by doing so, focus on the communication first in a way that was decoupled from the rest of the system, so that it could then handle load balancing and error handling later. And what he realized at the point is he actually had already created an object tool pattern without knowing at the time. And the way it says, like the way I derived to it was pretty much simply by encapsulating all the risky parts away. And then I say, okay, now that I have a minimal object pool, I have a way to communicate end to end. Let's focus on error handling. So there are 3 different levels. So the client is meant to be able to get another port to use and resend the message if an error happened. To the port that experienced the error, it should disable itself so that nobody else tries to use it again. The port manager is supposed to remember the port that went bad and get a new one to replace it. So with the decoupling that he had achieved, this was very straightforward. And something about this that I personally thought was interesting for me is that I probably would have gotten this wrong. Meaning, I would have, how would I say? He did a really good job here at separating what the error handling meant at each level, rather than say, oh, I need a error handling, and say, oh, probably it's at the client level and port level, and just do that without considering, port manager level, without considering the port level. Or some people say, what should I handle there? And I've done it, and I know other people have done it as well, where they pick one location and put all their error handling in the one location, or maybe two, but like error handling happens a little bit at every single level. So again, it said by decoupling everything, it made it very straightforward to implement. Throw an exception when an error occurred on the port, catch the exception on the client at the point of transmission. So pretty much like you'll be checking out, try to use it, you will get an error, catch the error, and pretty much you mark the port as bad and give it back to the port manager and ask for another one and try again. And then again, as a port manager, it could add a method called return back port, which pretty much does both the identify the port as bad, marking it, releasing it, and ask for a new one, and stuff like that. He also say if I couldn't get a new port, which is very unlikely, I will send a message via email by system administration, all the kind of stuff, like all the kind of administrative handling you put like inside of the port manager. And then it decided to go a little bit deeper, because it was like, okay, this all looks good, but what if something really odd goes by? Meaning, what if because the system, so it was bothered because the system was going to handle hundreds of millions of dollars, unsupervised. What if something goes bad in the middle of the night and people don't figure it out until later? So in Steve McGuire's book, Writing Solid Code, it's like to make it still things a little more robust, is like a dual checking method. It's a really good idea. And so he thinks of a separate independent mechanism of checking the communication so that he would not have to worry. Again, because he has these 3 different levels of abstraction, and everything is nicely encapsulated at each level. He gave another job to the port manager, and where he gave the additional responsibility of verifying the integrity of these ports. So it will have a thread that run a check every 15 minutes, which would see how many outstanding requests there are for the ports. And let's say, we can think about this, like, let's say if the array of ports is set to 5, but then you have a large queue, right? You could say, well, increase the amount of ports up to a certain level, right? And you might increase by 1, and then check again and do more stuff. But at this point, like Rancho said, see how many outstanding requests were for ports, query the ports for the status, whether they were active or not, and contrast this number with the number of requests outstanding to see if something was wrong. Meaning, if he has only 4 ports out of 5 that are active, meaning they're being checked out, but has 20 requests outstanding, it means something is not, either they're not getting checked in, or they're, the one that is free and supposed to be available is not getting checked out. And how many of these ports were in error condition, which in general should be at most 1 or 2, because as soon as you set them as an error condition and you bring it back, they should be disposed and replaced with a new one. And again, basically you could put anything you want in this code, expanding this idea if needed, and it will all have been because again, it's at the port manager level, it doesn't affect the client code or the port code at all. So you can do without affecting any of the rest of the code. So one of those observations that came out, the factors can do much more than instantiation. In this case, he's doing instantiation, he does management, check in, check out, all that kind of stuff, and error handling. Still image, think about still connections, connection that times out, all the kind of stuff you can handle at the manager level. Something they talks about, this is that you can start thinking about object as things with responsibilities. When you think about object as things with responsibility, it becomes clear how to separate these responsibilities. Now, I don't think this is very easy, and quite often you can trip yourself out by either making this responsibility larger or larger than they should be, or smaller than they should be. Like figuring out the correct amount of responsibility, because one could say the poor manager could handle should handle like the error handling, but the dual checking, probably a different object, and one could make a case for that. So the key feature of the object pool pattern, it branches again when we need to manage the reuse of object that's either expensive to create, or there's a little number of these objects that can be created. And the problem is the creation management object must follow well-defined set of rules, which include how to make the object, how many objects can be created, and how to reuse such objects. And the solution calls for a reusable pool. In this case, you could have like just a single acquire reusable method. There needs a reusable object. And if the pool is empty, then acquire reusable method creates a reusable object if it can. And generally, is done the reusable pool is a singleton. Somewhere in here it says that. The participants are generally the reusable pool that manages the availability of reusable objects used by the client. The client that uses the reusable object and calls the reusable pool to get the objects. Consequences. It says it works best when demand for objects is fairly consistent over time, which means if something takes a long, like a lot of memory, a lot of CPU, a lot of time to create, you cannot have something that asks for like 20, 30 in a row all at once, or like there's a big increase or decrease of this thing. Generally, it's like you should limit the number of objects that can be created, because one of the things is that these objects are expensive to create, and there's a limited resources. So, yeah, I guess that's one of the consequences, like when the demand for these objects is very consistent over time. Because imagine if you have like a 5 object available and you get 1,000 requests all of a sudden, you're gonna get a long queue behind it. Implementation. If there is a limit on the number of objects that can be created, or if there is a limit on the size of the pool, use a simple array to implement the pool. Otherwise, use a vector object. The object responsible for managing the object pool must be the only object able to create those objects. Thus, the reusable pool is implemented with a singleton pattern. And another area is to put a release method on the reusable object and let it return itself to the pool. And then a reference to the games of 4. And this is typical. The typical pattern is you have only one reusable pool object, which can have 0 or more client, 0 more reusable objects, and the client, through the reusable pool, uses the reusable object. And over here, you have the get instance. Get instance to get the reusable pool singleton object, acquire a reusable together, or release, or set the maximum pool size to increase in case there's a need to increase it, I guess. All right, let me see. I blew through this. In summary, it's pretty much in this chapter that it talks about how the object parent is used for two major reasons. It shows how to effectively can be used to instantiate and manage the objects, because again, it has this array of port, like in this case, port object. It loops through them, find the one that is not marked active, any use, give it to the client, and when it returns it, it loops through them and then marks the same object and mark it not in use anymore. Or if it's like it's a bad one, marks it bad, release the memory, get a new one, put it in the array. And then also does how encapsulation of responsibility assists developers in focusing on what they most need to. All right, what are 3 general strategies to follow when design? In this case, I guess it says tackle the highest risk thing first, encapsulate everything that changes, and don't build stuff that you're not gonna need until you actually need it. Focus on, which is branches says, focus on what's you need most at this moment. What's most important. Anybody else want to tackle the number 2? I'm gonna call Brett. What 2 parent does the object pool parent incorporate?
Next.
All right, factory branch is a factory pattern and a singleton pattern. What is the intent of object pool pattern?
To control things that are expensive to make.
Yeah.
Or limited.
And I said a bunch of times, what does the XP community means by YAGNI?
YAGNI means build everything up front without caring whether you need it.
Everything up front with
Yep.
that actually. Yeah.
You are going to need it. That's
You're going to need it. You are going to need it. Yeah, that's it. Actually works.
It's the opposite, of course. Don't build it till you know you need to have it. So a lot of times you guess wrong.
Right. I was actually impressed. Like again, like I really liked. Things with responsibility makes sense. I think how to do it correctly comes with experience, and I'm still struggling with that. The dual checking, I remember that I did read the Writing Solid Code. It's a massive book, but there's probably like a lot of really good stuff in there, but it's so big. And the thing in this, that consider what error handling meant at each level. This one, I don't think I do enough.
Yeah. I thought he left out the more complicated parts of this pattern. Like the primary, let's go with his example. You got 5 in the pool.
Mm-hmm.
And so, like he doesn't, I think he should have made some sequence diagrams for his whole, okay, I'm going to get a client. He had that one thing. Well, I believe his answer was, what if you don't have enough? You can only have, let's say you can only have 5. So number 6 request goes, the other ones are taking time. So he put a little line, well, then I use another thread to ask for it later. I think that's what he said.
Yeah, it says, I don't have one, ask me again in a little bit.
So that he's putting that on the client.
Yeah, somewhere.
And I think some people would put that on the port manager.
If one was not fine, I put the thread to sleep for 1 second and try again.
Well, he doesn't say where that is, but I got to say that has to be the client. Or
no,
that's in the manager.
That's in the manager.
Okay.
This is important. It loops through them. If it doesn't find, it pretty much sleeps itself. Like it does, and then it tries again.
Right. So once we start doing stuff like that, I fear things like deadlock or too many things. Too many things. What was it? Trying to retry. Too many retries.
Yeah, and pretty much like what you would do is like, you are accounted for like all the threads are asleep, and that's how like the dual checking. That's code. That's what it would do. We say how many threads are you running right now. So how many there are in queue?
Yeah. That's the sort of thing he goes, oh, this is in a lot of detail, the Java book. I say, oh, you should put more detail. Because that's the I think that's the more practical, tricky part.
All right. Let me go through the factory method patterns. So we finish, pretty much. So the factory method patterns is the simplest pattern there is, and generally is part of the template. Is by an extension to the template pattern. So in the template pattern, generally you have over here, you have like a method that calls a bunch of different things, right? You have over here it says like the do query method, it formats the query, return a data set, and then each subclass defines what those methods means for themselves. So the parent class doesn't know what each one of these methods actually means. They're all implemented in the subclass, and one of them is actually the one, make DB or DB connection, whatever it is. Here, if you have an Oracle query template or SQL Server query template, this make DB are gonna do their own thing. So this method becomes the factory, and because it's a method, it's actually called factory method pattern, which is similar to the template method, template pattern. So what it does is it actually standardizes the steps. And let me see, which one was not in the Gingos for this one?
Octopful was not. Factory method is
Okay.
Is one of the simple patterns. That...
Okay. And pretty much it says over here, say public or protected. Like in here, all of these hashtags signal that these are protected methods, which means that only query template or the subclasses can call it. If you wanted to call it outside, like a by client, you have to make it public method. But let me know if I'm scroll up and down too much. Yeah, so make the B method protected, the hashtag. Okay. I did say that. And then it's okay, factory method patterns and object-oriented languages. Pretty much is the factory method pattern has been implemented in all the major object-oriented language, and generally is with stuff like iterator, enumerable, and actually in C++, I'm not familiar with beginning. Forrest, are you?
You know, if I sort of looks familiar to me, but it's been like 20 years since I've done any. So
yeah, I don't remember either. I think last C++ stuff I've done was in NBA, somewhere around there. But pretty much, again, the iterator method on collection is the factory method, and it returns the right type of iterator for the collection being asked for. And this is quite often used by having parallel class hierarchies, like we're going to see over here. So you have a client, and you have an abstract collection, an abstract iterator, and the abstract have the count, the append, remove, and the create iterator, and the iterator abstract has first, next, done, current time, to get the current time, and in principle, like they mirror each other. You have a list, which will give you a list iterator. Whenever you say create iterator, the list will give you the list iterator. The vector will give you the vector iterator. The composite will give you a composite iterator. But create iterator over here is the factory method in the factory method pattern. So the intent is to define an interface for creating an object, but the subclass decide which class to instantiate. So you defer the instantiation to the subclasses. The problem, so a class needs to instantiate a derivation of another class, but doesn't know which one. So the factory method allows the derived class to make the decision. And the solution is to have a derived class with a template method that instantiate the correct class. And the participant are, just somebody's talking pretty loud next to me. So product is an interface for the type of the object that the factory method creates, and the creator is the interface to define the factory method. All right, let's look over here for a moment. So you have a creator and the subclass. So you have a factory method being defined. Creator doesn't really know what kind of object is going to be created. The concrete creator is going to create the concrete product of something else. So the consequences that the client will need to subclass the creator class to make a particular concrete product, which is the implementation uses a method in the abstract class that is abstract. Again, don't know this, don't remember. And the abstract class code refers to this method when it needs to instantiate a contained object, but does not know which particular object it needs. So essentially, in operation, it will say you might have a bunch of instruction, then you call whatever factory method you need to create the object that you need, and then you do something with it. And then this is a template method that the concrete class will define what kind of object is going to return. And so factory method is used in frameworks. It's most used when defining frameworks. This is because frameworks exist as an abstract level. So usually they do not know and should not be concerned about instantiating a specific object. So again, in active record phase, when it does a connection or actually active record adapters, you have a very generic adapter that have a make connection, establish connection kind of method, and then you have subclasses for SQL, for Oracle, for whatever they are, which will do the right thing and instantiate the correct object. So the adapter, I believe is an active record adapter, is probably uses some kind of factory method. and somewhere in there there's a connection. We use the object pool. All right. How many people have used this pattern?
I'm sure I have, but my comments on factory method is in general, it's literally as easy as you have a method that instantiates instead of you call it the constructor.
Mm-hmm.
And the benefit of that is the example they show here, that's the common example, is you have some hierarchy and you have subclasses that need to instantiate a different kind. So the whole, like, let someone else worry about what to do it is always in the move it to the subclass. The subclass knows, oh, well, the client only knows I call this method, like the right thing does. So as long as your subclass knows what method it needs, and it should know, you got it. So another perk of factory method is that, in fact, factory girl is exactly uses the factory method, is you use methods to create things. The difference with factory girl, and I think this is one of the good benefits that's not mentioned here, is that you can encapsulate logic. Get me a bank account, give me a checking account, give me a checking account with $5, give me, you can encapsulate in these methods complicated situations. Give me a bank account that's over withdrawn and has a limit of $22, and that could be a factory method with parameters, or that could just be a method with a name like that. And so you can see conveniently these things that you don't want a guy writing 22 lines of initialization code all the time. You just call it a factory method. The other thing is, in Ruby, factories and factory methods sometimes aren't necessary because you can pass the class and call new on it. So sometimes you'll see people will just pass the class object, and then you just turn around and say, well, class.new, and get something back. So depending, if you're doing factory methods with no parameters, sometimes you could just pass the class. And you can't do that in Java, C#, and most of the languages that are targeted by this. But yeah, okay.
Yeah, I'm thinking about that. Yeah, you can. Actually, I just did something where like you actually inject the object that's going to be inject the class that's going to be instantiated.
Yeah.
But yeah, I guess this is slightly different. I know that I use the template method a lot. I mean, it happens a lot for some reason. I think it's the most common one to find use for.
Yeah.
All right. What the factory is responsible for? Create objects.
Yeah.
What is the essential reason to use the factory method? Is when you want to pass the responsibility to create the correct object to a subclass. How many factory patterns have been implemented in all of the major object-oriented language? It's been provided for Java, so this way iterator, enumerable, and begin and end. What is it called? The factory method. It's a method that acts as a factory.
Yeah.
How does gang method pattern fit with other factories?
Yeah. Usually it's a method on the factory.
It's a method on the factory.
That is the default implementation.
Okay.
Factory class.method or factory.new.method, because it keeps all that creation in one place.
Okay. So the Gang of Four says that the intent of factory method is to define an interface for creating an object, but let's subclass to decide which class to instantiate. Why is this important? I think it's like it leads to cleaner code where you're actually encapsulating the factory closer to where it's going to be used.
Yeah, it's the responsibility in the right place.
Right.
And then it frees your client not to know the stuff because it doesn't care what kind of object as long as it gets the object.
Right. How should you go about deciding whether a method should be public, private, or protected? Well, public is only if you want it to be a public API, and like actually think about this quite a bit. I try to make small public APIs to my classes whenever possible. Sometimes it doesn't work out. And generally it's because I want to be able to change what's underneath as much as I can. I want to have like a very easy API to a class. Protected, again, when you want something to be used across classes and their subclasses. And private when there's like only like nobody else cares about this. This stuff that is implementation specific to a specific class. Think of one example where this pattern could be used. Well, I think I already did with the adapter, right?
Yeah, we could do that. I think a common scenario is like, let's say I have a game, I have a dungeon or something, and there's different kinds of rooms. There's a maze room, and a concrete room, and a something room. And if you're generating these randomly, just have a maker room, like the different subclasses. Well, the maze dungeon will have maze rooms, and the concrete dungeon will have concrete rooms. So the template is somewhere you do a maker room with a subclass. The maker knows what kind of room it is. Something like that for games. Maybe you do that for monsters.
So who wants to do the last two? I mean, the chapter 25 pretty much is the end of the book.
Which one is the one you just 24? What's 24?
There's 24 is just like a summary of factories. It's just like the last thought on factory in general. And then 25 is pretty much a review of the principles. Who wants to do it?
All right.
Am I going to call it?
You can call it.
I'm going to call Don.
Nope.
Nope.
I have a conflict on that Monday, unfortunately.
All right. I'm going to call Andrew. Andrew says he'll be delighted.
He's the king.
Do you hear him? Or says you're the king.
You're the king. Yeah. All right, we should pick the next book. Okay. So we pick it next session. Do we think don't we have some Safari points we need to use anyways?
Oh, they're expired.
They did already? Did you get something before it happened?
I commented, but I didn't use them. I said, hey, we had like 2 days. I sent out a message on Sunday last week or the week before. It was like on the Tuesday after they were expired.
Let's make a public Google Doc or something like that.
Yeah. To decide which one?
Yeah, with a list.
Yeah.
Okay.
That sounds good.
This one,
yeah,
not a bad book. It's partially based on the fact that most of this book I've been distracted, but this book is too dry for me. It's not too dry.
it's dense.
Too long. I don't know.
Well, I realized halfway into this, I really wanted to do the first edition. First edition, in my opinion, is much better a beginner book. This book kind of morphed into all these lessons he learned was not for the beginner.
Yeah.
I think there are definitely some chapters that are clearer than others.
Yeah, I don't know. It seems like the writing style like a little bit ramblish for me or something. Yeah.
And actually, I think in the Observer book, I think I found a line that said the opposite of what it meant. It's like a typo. There it is. All right. I guess let's conclude this one here, and we'll pick another book.
Yeah. Alrighty. Think about it. I might suggest refactoring. We could move from this into design patterns for Ruby. Refactoring. We look at TDD. If you think this is dry, the domain-driven development is impossible to read.
Domain-driven is oh my god, that is a snoozer.
Right. Patterns.
It's a good book, but it's snoozer.
Patterns of enterprise architecture has parts that are good, but it's big and comprehensive. So if you think this is dry, that's impossible to read. But those are really important groundbreaking patterns, of which many.
I'm okay with something else that's more dry. I guess I'm a little adverse to this author, to tell you the truth. Sorry.
Yeah, I'm just saying. If you can't, because this one I figure is fairly straightforward. It's not like, again, I realized it wasn't the first edition was much better in my opinion of saying, look, these are how patterns work in general, and look at these. And so it's like I don't think Magic Pool was even part of this one.
Well,
he came back. Whatever caused him to rewrite it, the first I almost think like he should have changed the name of the book. Because when I see Design Patterns Explained, I go, oh, I'm a beginner. Where do I start? Of which I thought the first edition was perfect for.
So
if I can find the old PDF somewhere.
So as topics goes, do we want to stay on something that is like very general like this, or something that is like maybe even more specific to a language?
Well,
like JavaScript, the good parts. It's a good book about JavaScript, and it's very quick and read.
We could do a shorter one. We could. I don't know if anyone's in a place to do a workshop. Again, I thought what could be appropriate is there's a patterns in Ruby book, which is of course more directly applicable. But now that we have a little bit of a general patterns idea, hopefully it needs more.
Do you only do that?
No, we only, first book is Pooter, and the second book is this one.
No, like years ago.
I think we talked about it. I don't think we actually.
No, I think we did.
Yeah.
If
we did, we never finished it.
We should read the news part of programming.
Send me the book that you're thinking. I'm almost sure we did.
Us also, yeah. Okay, all right. We can wrap up here. Thanks for coming, Nested Loops. We'll put a doc. Anyone who's not part of the team that wants to vote, I got to figure out how we're going to vote on those. We'll make a doc. Someone will make a doc and we'll publish it.
And hopefully you guys could follow me as I was talking.
Yeah. Good for me. All right. Thank you. Welcome.
See you.